Hey YouTube, another video, and this time I'm going to explain about positioning wheels and the positioning strips. I should have made this video about a year and a half ago, and in fact if you go back a year and a half then you will find a video of me taking apart some inkjet printer and showing the parts that I got out of it, and mentioning that I'm going to make a video showing how to use these positioning wheels, but there were more interesting things to focus on at the time. But hey, a year and a half later, here I am, and this is what this video is going to be about. So before we start, let's just have a look at this whole setup that I have here, a whole example that I made, just to make a clear point. We have the positioning wheel right here, you can see it, and a stepper motor attached to it. We're going to talk about the stepper motor in a few moments. Here we have the sensor, which will detect exactly the steps on the wheel. It's connected right here. We have a small setup, I'm going to mention it in a few moments again. Right here we have two Arduino boards. One is controlling the stepping motor. It has an L293 attached to it, which allows us, it's a dual H bridge, allows us to operate the servo motor, the stepper motor, sorry. The second Arduino controls the LCD right here, and it will also control the enable pins on the L293. So this one, this Arduino right here will provide the signals for the turning the motor back and forth. And this Arduino here will actually enable or disable the pin according to the position that it's counting from this sensor. We have three buttons here, which I'm going to show you in a few moments what they do, and a pot for the LCD for the brightness, some pull down resistors, some pull up resistors, diodes for the H-bridge, smoothing capacitors, a transistor which allows us to control the enable pin on the L293, and that's about it. This whole part of this whole setup is not really relevant to understanding how this wheel works, but since I wanted to make a complete example, then this is the entire setup. We're going to see how it works shortly. Now, first of all, let's start by talking about these positioning wheels. An important thing is that you can't really buy them as a consumer product. They're made specifically for applications like inkjet printers, which I took them out of. We have this form, which is a circle, and we also have a strip form like this. This strip you would find where the print head is moving. That's how the printer knows how far the head has gone and when to call it back. And this one is a circular, and this one sits mainly in the page feeding mechanisms, either the main feeding mechanism or the double-sided turning, or any mechanism where we need to know exactly at which position the page is at. The way that these wheels work is that, as you can see, we have a thin line at the end, at the edge of the wheel. And this line is made out of a lot of lines. One line is black and the other one is transparent. And this sensor here has two infrared LEDs inside with two infrared receivers. And once we have a black strip on one of the sensors, it will send out a low output. And if we have a transparent one, then it will send out a high output. We have four wires coming out of this sensor. We have voltage and ground, and then the two outputs of the receivers here. We will call them A and B, and we're going to talk about them in a moment. Now, this little print plate here, as you can see, it's a complete one that I salvaged. It has a brand here, I'm not going to mention it. But you will also find them just as part of a main circuit board, and in that case you would need to separate them, and you would end up just with the sensor itself like this. It has 6 pins, 2 for voltage, ground, 2 for the LEDs, you need to put a resistor on them, just like here, not to burn them out. And 2 for the outputs, which have a capacitor to smooth out the output signal and not get any sort of interference in between. So that goes about the sensor, the way that it's made. The way it works is that, again, we have an A and B output, and this wheel will turn, and on each movement, doesn't matter how much, it will stop at a certain position where either we will have a black strip on output A and a transparent strip on output B, or reversed. Or it could be in a sort of middle state where we have a sort of half black, half transparent on both sensors, or the opposite, where we have 2 blacks on 2 sensors or 2 transparent on 2 sensors, and we will get different outputs here, which we're going to see in a moment. An important thing that I want to mention is that in this example, just to make it as clear as possible, and because I only had these parts, I used a stepping motor. Now the idea is that these sort of mechanisms, these positioning strips, are not really designed to be used with a stepping motor. With a stepping motor we can actually count the steps that we're making, and the steps are fixed. So these are designed to be used with just a regular DC motor, which can allow us to make any movement at any degree, and it will give a better result. But again, since I only had this this entire setup here with the reduction gears and everything, I use a stepping motor, also easier to control, but you basically need to use a regular DC motor with it, and you will get much better results. And also the whole idea is that with this wheel and a regular motor, the manufacturer can produce a cheaper solution to getting an accurate measurement of position of a shaft or a mechanism that goes back and forth, instead of using a stepping motor with reduction gears, which is a more expensive solution. So that covers this part. Now let's start first of all by just having a look at what happens when we turn the wheel and we have the sensor on, and which sort of outputs we're getting. So right now the circuit is off. I'm going to turn the circuit on, like so, and you can disregard what happens here. Nothing will happen. I have both the Arduinos disconnected so that we don't get any interference. The wheel is connected, the sensor is connected. Here we have one LED. This one is the B output, that's how I decided to call it, and this one is the A output. And what you can see is, if I will turn the wheel, then we get these different outputs. One time the B is off and the A is on, one time both are on, one time both are off, and one time the opposite, where the A is on and the B is off. So when I do that, obviously when I'm moving it with my finger, I'm not getting an accurate movement, and that's why you're seeing this sort of random result right here. This is the output that you're getting. Let's show it for a few moments. And this is basically how this sensor sends the outputs from whatever position it sits on this wheel. So what I'm going to do now, once we get how these outputs are coming out, we either have a low state or a high state, it's all digital here. I'm going to turn the circuit off. I'm going to disconnect here a few things and connect the rest of the circuit right here. So just let me make a small adjustment here. I can remove these LEDs, and I'm going to turn the pull ups into pull downs. I'm going to connect the two input pins from the Arduino so that we can receive the signals in the Arduino. And I'm going to connect the power to it. And I'm also going to connect the power to the second Arduino. And now I'm going to turn it on. What you will see first, because I hardwired it into the code, is that it will make a movement of 200 steps, and it's not really important, but something that I didn't have the energy to change. So right now it started, we get here a number 201, hope that you can see it. Let's see on the camera. Yeah, I think that you can see it. Move the wires here a little bit. So right now I started it up. As I said, I put in the code some hard-coded values, and we made 200 steps, a movement of 200 steps in one direction. What I'm gonna do before I will show you how this whole circuit works is we're gonna focus on this wheel right here. So I'm gonna for a moment disconnect the motor, and I'm going to recalibrate the wheel to put it on 12 o'clock roughly. You can actually see the steps here going, but that's not important at this stage. I'm going to do it just one movement to reset it and again disconnect it. So now you can see we have 1 here on the display. We've reset it and we're sitting on the 12 o'clock on this wheel, and I'm going to manually turn it. You can see that we're counting the lines, the steps that we're getting here. I'm going to add a picture at the bottom of this wheel through a magnifying glass. You'll be able to see what these lines actually look like. But I'm going to make a whole rotation, and that's just to sort of make a point that we need to talk about. So I'm rotating it. There is a certain limit that you can of speed that you can rotate this wheel. If you rotate it faster, you need to have a faster mechanism of detecting these input-output signals. Normally in a printer it will go quite slow, but here also, since we're using Arduinos, we need to be careful with it. I'm going to stop now. We have 900 on the display. We counted 900 steps, and as you can see, we moved from the 12 o'clock position to the 6 o'clock position, and that is exactly 900 steps. So I'm going to continue on further. I'm going to continue rotating the wheel until I reach the 12 o'clock position again, and then we're going to talk about these numbers and what do they actually mean and what sort of options they give us. So we're almost there, and I will calibrate it just by looking at the screen. Hopefully I get it right. There we go. 1800, and we're back on the 12 o'clock position. Now 1800, this number, it is important. If we look here on the wheel itself, some will have these numbers on them, some won't, but right here we have a number. It says 1800 CT, 200 LPI. What this means is that we have, first of all, 200 lines per inch. So if we just measure the whole length of this, the outer diameter of this wheel, we will get 200 lines per inch. And this entire wheel makes up 1800 steps. Now, not lines, but steps. And each step is made out of a single line, which is black, and the line next to it, which is a transparent line. This is important to understand, because when we measure the signals, if we want to get 1800, if we want to get what this wheel say it's designed for, the way that we measure it is that we have an A and B output, and we only note the states where either A is high and B is low, or B is high and A is low. If we measure both states, then we would actually get 3600 steps, because we're measuring each separate line. So the black line and then the transparent line. But if we want to use it just the way that it's used, and with the numbers here that would indicate 1800 complete steps, then we need to measure only one state, which is either A is high and B is low, or B is low, or B is high and A is low. That's how we reach this number. What does this number mean? Well, first of all, if we have 1800 steps on this wheel right here, and we divide it by 360 degrees, then each degree would be made out of 5 steps. And 5 steps means that we can make a movement of 0.2 degrees for each step. If we measure 2 states, so if we will count both the states where once A is high and B is low, and then we're also going to measure when the state changes to B is high and A is low, then we will get 3,600 steps, and that means that we can make a movement of 0.1 degrees for each step. And for each line, not a step, because a step is made out of 2 lines, but for each line. So we're actually doubling the amount of accuracy that we can get out of this wheel. That sort of covers the way that the wheel works and the way that the sensor works, the outputs that it's giving, the way that the outputs are registered here on the Arduino, and you can see right here on the display. Most of the work here is done through the code. The circuit that you see here, basically most of the circuit is just to run the stepping motor. And again, as I said at the beginning, the intention is not really that you use a stepping motor, but I didn't have a different solution that I could easily implement. Another thing is that you don't need to actually use 2 Arduinos. The reason why I used 2 Arduinos is because I was too lazy to make a proper driver with an L297 and an L298 and a clock, and then I could enable it just from one Arduino. So I went the tomato route, and I just used the internal libraries for driving a stepper motor with this L293 dual H bridge. But the internal libraries, they have delays in them, so these delays prevent us from getting an accurate measurement from the sensors, so I had to separate these two. So here we have one Arduino which only controls the motor, and here we have one Arduino which controls the sensing of everything and has pretty much no delays inside and just works on clock speed. So that's it about the circuit. Next, we're going to do some demonstrations here. We covered up some numbers, and you know how these lines are divided and how much accuracy we can get from them. With counting 1800 steps, we can get a 0.2 degree movement for each step, and if we were to double it, then we would get a 0.1 degree movement. So I'm going to connect the motor controlling Arduino. I'm going to connect it back to the circuit. You can see we're on 12 o'clock. If we divide 1800 by 4, we will get 450. And 2 times 450 is 900. And 900 is half a turn of this wheel. And 450 would make it a quarter turn. Now I'm going to show you some movements here. Again, this is not a precise mechanism that I've built inside the printer. Everything is built up with a high degree of accuracy, and here I just used one screw and everything is rattling, and there is no oil, no lubricant in the gears here. We're going to see that in a moment, so it's going to produce some sort of misreads here. But this example covers the point, and we did it manually, and we saw that everything is accurate. So here I added 3 buttons. The first button will allow me to make a movement of a quarter turn. So essentially it will move from 12 to 3, and from 3 to 6, and from 6 to 9, and from 9 to 12, with some inaccuracies in it. Again, that comes from the mechanism. Also, an important thing is that since we are dealing with light here, you always need to make sure that these wheels or strips, they don't have any fingerprints on them, they don't have any dirt on them. Here, as much as I tried to keep it all clean, I already have dirt here, some dust that sits right here. Right now I'm talking, so I actually did a little bit of spatter here on it, but it will all work fine for this example. The second button will allow us to make increments of 10 steps. The third button allows us to make increments of a single step. So let's start off by just having a look what a quarter turn looks like. And on the display here, you will be able to see the counting and how many steps it counts, and also how many steps it will count accidentally just by the movements here, which is 1, 1, 2 steps. So let's start off with a quarter turn. We have the number 451. The 1 is a discrepancy that comes from this mechanism. This gear is not intended to be used with these gears. There is some slippage here that goes on. Any tiny thing that I touch this mechanism would cause it to move just slightly and add another step right here. And that's how a quarter turn actually looks like. You see that it counts the steps. I'm going to put the code also in this video. It's not complicated things, but then again you need to understand the whole idea in order to make something out of it. Next we're going to look at just 10 steps. So this was a movement of 10 steps. Again, these two buttons, the way that I've implemented in the code is that I can just press it and they would move. Once I press it, it basically activates the enable pin on the L293, causes the motor to turn, and once I release the button, then it actually starts counting the 10 steps. The last button that I've made is a single step movement, but this one, unlike these ones, if I press it once and I hold it, nothing will happen. So I just press it once and it will make a single increment. Just like that. And here on the screen you just saw we had a 3, here we have a 2. Again, that comes from slippage here. You're not supposed to use a stepping motor in this mechanism. A stepping motor gives you fixed movements. So if you want to actually use a wheel like this with a stepping motor, you need to figure out the gear ratio, you need to have everything precise. If you use just a regular motor with, doesn't matter which gears you use, or if you use just a pulley belt, a DC, just a regular motor will just rotate and stop when you stop it, and it gives us a much smoother movement, not in step increments, just like a stepping motor. So you would get much better and more accurate results. But again, just to make a point here, I used this and I explained everything at the beginning. So that's the way that these wheels work inside the printer. And if you want to salvage it, if you want to use it, again, you need to salvage it from some sort of a device. But once you have it, there are numerous uses that you can make for it. For starters, I'm thinking about a rotating camera mount, which if you buy it from a brand or if you buy something high quality, then you would end up paying a lot of money. And you can pretty much build it yourself if you know how to use these sort of things and just connect a cheap motor to it. That was about it. That was the explanation. I added the circuit schematics, whatever I needed to add. There are no schematics for these things. There are previous videos that I made, how to use an L293. Arduinos, you should know how to use them if you're watching this video, and if not, then there are previous videos that you can learn from it. And yeah, that was about it. I hope you liked this tutorial, and I'll see you next time. Thank you for watching.